Good afternoon, grade 12. Today's lesson, we are going to look at the inverse function of a parabola. Now, before we take a look at the parabola, let's quickly recap what we know about the inverse functions. We know that the line y equals x is the mirror or the reflection line of the function and its inverse. So, if I ask you, what is the reflection line? We can write y equals x. There's also a specific notation when you work with inverses. The normal function has an fx or a gx or whatever, and the inverse has a f to the power of minus 1 x or g to the power of minus 1 x. So these are the inverse notations and these are the function notations. To get an inverse, you swap the x and the y values. And we also need to know what a function is. Can you remember? A function is a graph, let's say the straight line, where if you use your ruler, the function or the ruler cuts the function only once as you move along it. Now, the parabola, if we give you a function y equals x squared, and I want the inverse of the parabola, we know that we have to swap the x and the y's. And then you have to solve y. So we get the square root on both sides. And remember, the square root always have a plus or a minus value. Now, if you draw the normal parabola, the blue one, it will look like that. And if you draw the inverse function, it will look like this. But the inverse of a parabola is not a function, because if I do the ruler test, my inverse cuts my ruler every time at two places. So this is not a function, and we cannot write f to the power of minus 1. However, we can split the normal parabola into two parts. This leg and that leg. And that means that we restrict the domain of this parabola from the turning point x value to x to the x smaller or equal to 0 or x larger or equal to 0. So we use the domain and the turning point to split our parabola into where the x's are smaller or equal to 0 or where the x's are larger or equal to 0. And then, if you only use that half of the parabola, you will get this half of the inverse, and that is a function. Or, if you only use that half of the parabola, you only get that part of the inverse, and that is also a function. So the inverse will then be a one-to-one mapping, and that is a function. Okay, let's look at an example. We're going to do example 1 of your notes on page 4. Again, we have y equals to x squared, and we draw a table to get a perfect parabola plotted on our x and y axis. To get the inverse, you can use this table and just swap the x and the y. So the x's are here and the y's are there for my inverse. I showed you now how to get the inverse formula and we draw them. We notice that this is not a function and we cannot write f to the power of minus 1. We notice that this is not a function, and therefore we can't write f to the power of minus 1. So we restrict the domain. And we use the x value of our turning point. So this is our turning point's x. And that is our turning point's x. If the x's are smaller or equal to 0, we only have this part of the normal function. And if we get the inverse of this leg of a parabola, it will be this one. And this is a function. However, if you look at the other side, other leg, for x larger or equal to 0, the inverse function will look like this. Let's look at example 2. If we have a function of a parabola, our turning point is very important because that will indicate only the x value of the turning point will be the indication of where we're going to cut our parabola. So we get x is 1, but let's complete the turning point. Y will be 0. We draw a table to plot the normal parabola. We swap the x and the y's. So you just swap it. Now x is 4 and y is minus 1. X is 1 and y is 0 to get the inverse. But this is not a function. How do I get the inverse function name or the inverse formula? We use the normal parabola and then we swap the x and the y's. So here where there was a y, it becomes an x. Here where we had x squared, it becomes y squared, etc. Factorize and get the square root on both sides. Solve y by taking the minus 1 over to the left hand side. So f of minus 1 of x will look like this. But we know that the parabola inverse is not a function. So we have to restrict the domain so that the inverse is a function. The turning point was important, the x value. So we say x will be larger or equal to 1, so it will be this part of the parabola. Or x will be smaller or equal to 1, and then it will be the left-hand side of the parabola. And the corresponding inverse halves will look like this. And there, by restricting the domain, we can get the inverse as a function.